viewer, welcome to my channel again. So this time we'll discuss the multiplicative law of probability. So earlier we have discussed the additive law of probability, and this time we'll discuss multiplicative law of probability, and this is also known as theorem of compound probability. So in this law it is explained that probability of the simultaneous occurrence of two events A and B. Suppose there are two events and the probability of occurring two events simultaneously is equal to the probability of A multiplied by the conditional probability of B, given that A has already occurred. So in this case, conditional probability will be used to find out or to explain the multiplicative law of probability. In other way, we can say that it is equal to the probability of B multiplied by the conditional probability of A, given that B has already occurred. This means probability of simultaneous occurrence of two events A and B is equal to probability of A into probability of B given A. That means A has already occurred is given A is equal to probability of B into probability of A as B has given B has already occurred, or A given B. We can say A given B. Same, because we do not know which one will come first. So probability of A, B, joint probability or a simultaneous occurrence of two events. So if A occurs first, then this is probability of A into probability of B given A, or equal to probability of B into probability of A given B. Now how to prove it? Again, let there are n number of mutually exclusive and equally likely cases. Suppose there are n number of cases. Out of it, m is the favorable cases to event A. So the number of favorable cases to event A is m. Then m1 favorable to both the events within m. So within m there are m number of favorable cases to both the events. So n number of, so we must remember that n number of mutually exclusive and equally likely cases, m are favorable cases, and m1 are favorable to both the events within m. Then probability of the events A and B occurring simultaneously, that both the events will happen, is equal to probability AB is equal to m1 by n is equal to m by n into m1 by m. So probability of A is equal to m by n is equal to PA. In occurrence of A, equally likely cases are m. Within m cases, within m cases favorable to A, the left out of which m1 are also favorable to B. So ratio m1 by m represents the conditional probability P, probability B given A. Then probability of B given A means A has already occurred. Then probability of AB, that means occurring both simultaneously, is equal to probability of A into probability of B given A. Now, as AB is a compound event, that means they occur simultaneously, then symmetrically probability of AB is equal to probability of B into probability of A given B. Now, corollary 1, if A and B are independent events, suppose A and B are independent events, then probability of B given A is probability of B. So in case of independent events, probability of B given A is probability of B only. Then the above theory of compound events is probability of AB is equal to probability of A. Now corollary 3, probability of AB given C is equal to probability of A given C into probability of B given AC. Now N represents the total number of equally likely and mutually exclusive events favorable to C. Then corollary 3, probability of ABC is equal to probability of A, probability of B given A, and probability of C given AB. So must practice and remember these three corollaries, and the multiplicative law of probability, that when two events occur simultaneously, and what will be the probability when the probability of one event already occurs. So if A already occurs, then probability of this. If B already occurs, then probability is this. So we can, both are true, because if A comes first, then this is the one. If B comes first, then probability is this. And this is our explanation. So we'll have to remember and practice. And thank you very much for watching. Please subscribe. Thank you.